purpose of this study was to determine phosphate, nitrate, and lead levels in Crescent Lake, south of Monroe, Washington, while also exploring the implications of these levels on environmental health. Only 0.009% of Earth's water is freely accessible fresh water. The vast majority of Earth's fresh water is located within the polar ice caps or lies underground in springs. 77.8% of this 0.009% is found in lakes, which are seen as the most valuable sources of fresh water on the face of the Earth. These lakes can also be valued as sources of tourism, recreation, transportation, and wildlife. The Crescent Lake Wildlife Unit refers to a 360-acre plot of forest, farmland, lake, and swamp purchased by the Washington Department of Fish and Wildlife in 1974. 110 acres of this is sharecrop farmland, where cereal grains are left standing to be hunted. The lake itself is 10 acres. Previous studies have indicated the presence of lead throughout the lake, though lead seemed to be most concentrated in the southeastern tip. Crescent Lake is also fed through subterranean flow by the Snoqualmie River. Lead poisoning has been recognized as an environmental hazard for over a century and has been proven to have adverse effects on vertebrates when ingested. Lead has been shown to have many behavioral, immunological, physiological, and reproductive effects, ranging from muscle weakness and lethargy to anorexia and even death depending on the degree of poisoning. The Ecological Soil Screening Levels, or ECO-SSLs, established by the United States Environmental Protection Agency, or EPA, for avian, mammalian, plant, and soil invertebrate health are 11, 56, 120, and 1700 milligrams per kilogram dry, respectively, while the Washington State average concentration of lead in soil is 14 milligrams per kilogram dry. Many organisms are exposed to lead through lead ammunition. Though lead ammunition was banned for use and sale in 1991, spent ammunition can remain in the soil for up to 300 years. This leaves waterfowl particularly at risk for lead poisoning, as they may ingest lead pellets as grit or simply while ingesting aquatic vegetation and invertebrates in their diet. Phosphate loadings have been shown to have detrimental effects on plant and algae communities. Phosphate increases plant growth rate, disrupts the species composition of an area, and promotes algal growth, which can decrease light penetration. Phosphate loadings have also been shown to decrease dissolved oxygen overnight. The EPA thresholds for hypoeutrophy, which is defined as the status of high nutrient levels and consequently low dissolved oxygen levels, is 100 micrograms per liter. The EPA threshold for oligotrophy, defined as the status of low nutrient levels and consequently low primary production levels, is 10 micrograms per liter. Phosphate has been shown to come from many anthropogenic point and non-point sources. Point sources, meaning that phosphate can be traced back to a single specific location, are often dominated by the output of sewage and other degradable organic materials. Non-point sources, meaning the phosphate cannot be traced back to a single specific location, include agriculture and urban runoff. Nitrogen has been shown to have or to cause acidification and phytoplankton blooms in affected areas. Nitrogen must be converted to an active state, such as that found in nitrate, before it can be used. This can be done organically, by specialized organisms, or through human activities such as the combustion of fossil fuels and the manufacture of fertilizers. Not all plants respond equally to the addition of nitrogen fertilizers, such as nitrate, and some plants are not equipped to combat more competitive plants. Thus, the loss of biodiversity is often the price of nitrogen pollution. The United States average concentration of nitrogen in water is 2 micrograms per liter, which is not harmful. It was hypothesized that lead levels would be above the state average of 14 milligrams per kilogram dry, phosphate levels would be within the EPA thresholds for hypoeutrophy and oligotrophy, and nitrate levels would be above the United States average. Data were collected on February 2nd and February 28th of 2014. 2 water samples and 4 sediment samples were collected on each of these dates. Water samples were collected from the surface of the water column using a syringe, while sediment samples were collected using a core sampler. The 8-inch core samples were divided into 2 separate samples, one from 0 to 4 inches and one from 4 to 8 inches, to be analyzed separately. Samples were analyzed using at-home testing kits before being sent to outside laboratories. Water samples were sent to the University of Washington Marine Chemistry Laboratory to be analyzed for nutrients, while sediment samples were sent to the Everett Environmental Laboratory to be analyzed for lead. Phosphate levels averaged at 0.40 micromolar, or 38 micrograms per liter, amounting to 12 micrograms per liter of phosphorus. nitrate levels averaged at 0.025 micromolar, or 1.6 micrograms per liter. Phosphate levels remained fairly consistent throughout Crescent Lake, though they did seem to decrease towards the northwestern tip and increase towards the southeastern tip. Nitrate levels remained similarly consistent throughout Crescent Lake, however they increased towards the northwestern tip and decreased towards the southeastern tip. Lead levels seemed to increase with depth but showed no clear locational trend. Surface levels averaged at 29.6 milligrams per kilogram dry, while deeper levels averaged at 31.1 milligrams per kilogram dry. The overall average across all 8 samples was 30.4 milligrams per kilogram dry of lead. The hypothesis that phosphate levels would be within the EPA recommended range of 10 to 100 micrograms per liter was supported, though phosphate levels averaged towards the low end, nearing the threshold for oligotrophy. This is likely due to phosphate's tendency to bind to particles, including soil. These low phosphate levels have the potential to disrupt the species balance of Crescent Lake, as not all plants respond equally to lax or to decreased phosphate levels. These could also adversely impact local fauna's ability to find shelter, locate breeding grounds, and feed. Thus, phosphate levels may only directly impact plant and algae communities. They can have cascading effects throughout an ecosystem. The hypothesis that nitrate levels would be above the United States average was unsupported, as nitrate levels were very close to the United States average. This is likely due to the subterranean flow from the Snoqualmie River. As water is constantly exchanged between Crescent Lake and the Snoqualmie River, it would be difficult for nitrate to accumulate in the lake, as nitrate does not bond to particles as phosphate does. However, as fertilizers are constantly applied to farmland surrounding Crescent Lake, it would be difficult for subterranean flow to completely remove nitrate from the lake. These average nitrate levels are unlikely to disrupt the species balance of Crescent Lake. The hypothesis that lead levels would be higher than the state average was supported, as lead levels were significantly higher than the Washington state average concentration of 14 milligrams per kilogram dry, ranging from 18.3 to 52.4 milligrams per kilogram dry, and averaging at 30.4 milligrams per kilogram dry, which is more than 2 times the state average. These high levels are likely due to hunting activities in the farmland surrounding Crescent Lake. Decreases in surface lead levels are likely due to decreased lead input, which supports the theory that lead is supplied to the lake by ammunition, which would likely decrease after its ban in 1991. All recorded lead levels were significantly greater than the ECO-SSL for avian wildlife, meaning that these lead levels have the potential to adversely impact bird populations. Phosphate and nitrate levels were not higher than average or outside of safe levels. Phosphorus from phosphate levels were close to the threshold for oligotrophy but have not reached this point. Nitrate levels, however, were very close to average. Lead levels were much higher than the Washington state average of 14 milligrams per kilogram dry and were well above the ECO-SSL for avian wildlife. These conclusions are tentative, likely mostly due to small sample sizes, and further research is needed. Research of other parameters, including temperature, flow, bathymetry, chlorophyll levels, and phytoplankton populations, could also help to form a more concrete conclusion on the health of Crescent Lake.